I'm really happy to be here at PyCon Taiwan 2025. I'm Jeff, and then I'm going to talk about how we help K-12 students write their first line Python. And then we just built a game-based learning platform using Pygame, and it's called KangaCode. And for those Taiwanese people who are not really familiar with what K-12 is, K-12 is from kindergarten to the high school in Taiwan. You know, it's kind of this kind of relationship. So who we are? Our company is called Rollitech, but we have the doing business called KangaCode, and we are based in Pittsburgh, Pennsylvania, the States. And then our product or project is backed by Carnegie Mellon University Swart Center for Entrepreneurship, and we also got some credits sponsored from AWS, Google, and Microsoft to build this product. And this is today's outline. So I'm going to talk about the educational design, the kind of like educational philosophy behind the approach and then this product. And then, but I also cover, because this is the 45-minute session, so I also cover some technical parts, like how we really build it, and then like how we handle the code that students submitted with us, and then how we parse it, and then how we store it, how we analyze it. But the main focus will be the educational part, and then to the technical part. And then we will have some live demo, and then we will share some challenges we face, and then reflections, and then stuff like that. And then we'll have a closing, and then QA session. Okay, so the question is, the frustration of traditional learning. So I believe everybody, not everybody, but most of people here are really familiar with how to write Python code. And then a lot of people learn how to write code or Python, starting from the textbook or a command line. And then you guys learn what is REPL, REPL, and then turn on the VS Code, JBranch, a lot of tools, and then you don't know what that is, and then you'll see a lot of jargons and then symbols there, and then what is that arrows means, what is that dot, you just don't know, and then the teacher or the textbook just tell you, okay, you could write print hello world, and then you just print hello world there, and then you don't really know what the print is, just showing some words in a terminal, and then. For people who are not familiar with Python, you may wonder what this terminal is. So there are so many jargons there when you are learning a language, because not everybody wants to be an engineer. Some people just want to know Python to do some simple task or automatic task. So this kind of traditional learning, for K-12 students, for beginners, for young learners, or even for everybody who tries to learn Python is a huge problem. Yep. So, like I said, the traditional materials or method got some problems. So the first one is too abstract. So you are not really, you kind of don't understand what that is at the beginning. The learning curve is kind of huge and then steep. And then, so there are so many terms, variables, function, loops, and then what that is, you don't know. And then hard to relate. And then some textbook and most of textbooks or teachers teach Python using math or some science topics, like how you calculate some 1 to 100 or using some math formulas to try to teach you Python, but you are learning math instead of Python, right? So that's another problem. And then the third problem is kind of boring. Yeah, so like I showed, you see terminals, you see those kind of code editors, and then it's just not looking good. So it's boring, and then it's not visualized well, and then it's kind of like set you back to learn whatever you're planning to learn. Yeah. So like the host just mentioned, there are a product or a project from MIT called Scratch. This is for the young learners and then also K-12 students or any kind of beginners. And then they try to visualize, they try to solve the problem I just mentioned in the previous slide. They try to solve that visualization problem, try to solve that boring terminal stuff. And then, the problem Scratch is, do you guys really know what that is? So when you open the Scratch, you don't know what to do next, right? Just blank. And then there's a cat there. And then there are so many blocks right there. And then there are some so-called functions, but you don't know what's the next step, what the next step is. There are no instructions. There are no no guidelines, and there are no concepts you are going to learn there. So you don't know what you are learning and what you are going to do. So so limits of Scratch, there are some. So for the first one is like I said, so there are no instruction, and also that blocks is not a real code. So after you learn how to write Scratch, you are not really able to write actual code. And then even for the everybody so-called simple language Python, you are not able to do the transition well. So there are also significant gap between transitioning to, from text block-based coding, this so-called coding, and then to the text-based languages like Python. So there are some limitations. So I think Scratch could actually train kids or beginners the coding logic, but they are not really writing code. So there are some research from some people, and then studying how we transition from the block-based coding to the text-based coding, and then there are some gaps there, and then it's basically just what I mentioned. They're boring, and then you don't know what to do, and then you're not really learning code, stuff like that. So so like you can see the subtitle there. So block-based programming environments may provide gentle introduction to programming, but the transition to text-based languages remains a significant hurdle. So I think the question for us or for people who want to solve this kind of problem or this kind of gap, come up with these two questions. The first one is, can learning really be really fun and real? The real here means you're writing real code like Python. And then can kids play Python from the first line? So like, from the beginning, you're writing actual code. Yep. So that's why we built KangaCode. So it's a game. It's an RPG style game. And then we use pixelized styling arts. And then we will provide, and this platform will provide instructions. It's like you are really playing RPG games. And then you need to write actual Python code to solve any kind of challenges or quests or anything you encounter. Basically, you're playing games. So yeah, so we use real Python syntax and the RPG style, pixelized styles. Characters can be controlled through Python commands, and then there are instructions, quests, and challenges. It's like you're just playing. So our vision is not every child needs to be an engineer, but our goal is to make everybody, not necessarily to be child, but everybody who wants to learn Python, love programming. Yeah. Okay. So this is kind of okay, thank you. So there are some methodologies here, and this is kind of boring. I'll demonstrate the real product later very soon, but I'll talk about this boring stuff first. Game-based learning. So each level is each quest. So students process through a narrative adventure, which means like I just show you the Scratch. You don't have instruction, you don't have guidelines, but we will give them what to do next, and then what you're going to learn here. Yeah, and then the second is completing tasks, and it's kind of like we're building achievements, a sense of achievement for students or learners. So we will have you have a backpack. You could collect coins. You could collect equipments, a lot of stuff, and then fancy equipments, fancy characters, skins. You're just like playing games, real games, and then we'll have some rewards for learners who really did a good job in a certain level or quest. And third is, and then we believe, and then this kind of methodology kindly prove, and a lot of research do that learning could be playing. So, you're playing, but you're also learning. So, educational content is really similarly integrated to the gameplay mechanics. Okay. So I'll use this example first, but believe me, I will demonstrate it very soon. So this is the traditional approach, like I just showed earlier. So print hello world, and then you just got some output, and then for that hashtag, for some people who don't know that is a comment, and then so there's some jargon, and then learning, and then but we predefine some objects and methods in a game, and then the students or young learners or beginners could, they don't need to learn what the object or what the method is first. They could just understand, oh, there is a character called Kanga, there's a character called something, and then they got some methods. Methods could be skills, could be movement, could be whatever actions. So they could call the item or the character first and use dot to use their actions or methods. But this is kind of related to the object programming, but we will not teach that at the beginning, but they are writing object programming code, and then they are real code. Yeah. Okay, so and then traditional learning, you'll get a lot of syntax, and you will need to set up environments when you install VS Code or when you open repo and when you open JetBrains, a lot of the code editors, and then a lot of scenarios where you will face a lot of configuration problems. You couldn't find a path. You couldn't get a lot of this kind of syntax error. But our syntax error, we kind of wrap it to some friendly instruction. But we will provide the actual error message to them as well. But we will kind of alleviate their pressure or learning curve to accept or to at least try real programming language. Let me check the time. Okay. Okay. So, so this is another example that traditional learning and then game-based learning, especially chemical code, difference. So when you're learning a for loop, and then you may try some math problems like print the multiplication table, sorry, and then you will try to you will face the nested loop and then a lot of things, and then teacher will explain what the range function is, and then what is argument and stuff like that, and then after you finally figure it out what that is, but the results may look intimidating because you just got a table and then there are so many figures there, and then it's not that interactive or visualized. So, but if we use game-based method, we could set up some challenges, and we could set up some plots, and then they just try to solve those plots using for loop, like collecting coins, and then those kind of repetitive tasks. Yeah. Okay. So before going to the technical part, like how we build it, let me do some demonstration first. Yep, this is our, you could say MVP, or you could say beta version, or you could say version 1 version. And then this is our main character. His name is called Kanga, but we'll have a lot of different characters in the game, and a lot of different plots and scenes. And this is the first level, so we use level-based learning as well. So we have different levels for different difficulties, teaching different programming concepts like loops, variables, functions. Even for advanced like algorithm, we will have advanced levels as well. Okay, so the difference between Scratch is like I just showed, everybody just saw the Scratch. So you kind of don't know what to do next, and then you'll drag whatever blocks. You see the blocks at the very first beginning, but right here, when you see this picture, I believe everybody just want to try to use their keyboards to move the characters here or something, and then you will try to see what you could do here or something like that. But when you go to some certain places, but it will improve that as well. But when you go to some certain places, you will show some instructions and what you could learn here in this certain map, and then there are some challenges. So when you go to a challenge, and then you will see the instruction, what you're going to do and what the task is. And then we are not telling you the programming concept right away to intimidate you, but I just tell you the instruction like you are just playing the game. So for this, we could, the text is not that large, but I'll read it. So the text here is, let's begin with the very first line of code. You'll help Kanga say, hello world, a classic tradition when learning programming. So, and we have some simple tutorials here. But as you can see, the characters here, and we block your keyboard at the beginning. You must use code to solve this quest first. And then we will unlock your keyboard so that you could play the game afterwards. So it's, combine the learning and the play. So everybody remembers the goals here, right? You need to make Kanga says, where's my cursor? Okay, Kanga says, hello world, and then the code is right here. Okay, so we could just run. And the Kanga say, hello world, and then we solve this problem, and okay, click done. And then we will have some interactive animation or gameplay there, or some monster will show up and to chase you or whatever, and to force you to the next level. So you will, and like I said, after you use real code to solve this problem, we will unlock the keyboard for you, so you could actually play the game like this, and then you could go to the next level by hitting this red flag, and then to the next level, you'll see the next challenges and the instruction. Stuff like that. So let's just play some challenges for you. So this is say something else. So say anything. So for teachers, so if you are a self-learner, you are playing games, but you are writing code. But if you have teachers to guide you, they could also add some information. The teacher could have some additional or supplement additional materials to this, like how we might map this concept to the print or the traditional concepts and stuff like that. Or we could introduce the basic object and the methods here as well. What an object is, what a method is, but we will not talk about polymorphism right here. We just talk about the basic. Yeah, right? Okay, so say something else. So you could say my name. Sorry. It's a little bit laggy. Okay. Okay. So these are free trials lessons, and then if you sign up for a free account, you could try this free trial lessons, and they are not really difficult, but it's just like a trial. And then we just learned one method called say. But we will have some other predefined methods like move down, move left. And then this quest is to collect a gold coin. So you need to move down one step and then move left one step, like what I just write here. So you collect the coin and then solve this problem. And then, like I said, we unlock the keyboard for you. So if you want to collect that blue coin, you could. And then we will have some other, this kind of animations or hidden challenges for you to actually play, and then you could go to the next level if you, or the teacher forces you to go to the next level. Yeah, and okay, so for this one, we could use, we need to collect these 3 coins for writing 3 steps. So let's imagine together. So we could write Kanga.move up, and then Kanga.move up, and then Kanga.move up. You could write it 3 times. And then you could have the kids to write it 3 times first. And then if you're a teacher, you could use this case to teach for loop. So we could actually write a for loop. Okay. And then when you move up 3 times, you need to move right 2 times. You could also use the for loop as well. Okay. And then hit run. It'll give you the corresponding animation. And then if you're a teacher here, you could teach the students whatever concepts you are going to teach, but we just visualize the concept with game. Yeah, this is a basic idea. So let's switch back to the slides, or let's see if we have another free trial. Yeah, we also got some free trials. But if you want to try some free trial challenges, you can sign up free account. We provide some free trial challenges. But if we have time, we could switch back to here and then let's play together. But let's go back to the slides first, because I believe some people want to know some kind of technical parts. So I'm not just talking about the education stuff. Okay, so the next, let me get some water. Okay, so the next part is how we build it. I will not go too deep in the technical part, but I'll give you some overall architecture or concepts, like, and then what kind of packages we use and to build this. And then if you have certain questions, you could leave your questions to the Slido, or I just forgot what I call Slido, or some places, and then I may answer you later if I could. So okay, so how we build it. So the system overview, I'm just focusing on the backend instead of the website stuff, because we use we also have website. You can see your collection, you can see your packages, you can see your whatever equipment you earn from the game. But I'm just focusing on the game side and the backend side. So as you just see, we have a customized code editor. So we basically build that editor ourselves, because Pygame doesn't provide that package. So we just build that editor, and then we write some methods, and then custom packages to read their code, to analyze them, to parse it, to execute it, kind of like that. And also this kind of colors, we build that colors as well. Yeah, because Pygame doesn't provide that. So code editor, and then like I said, when students write code and then they hit submit or run, and then how we are going to judge or determine if their code are valid, and then as well as if their code is able to pass the challenge or not. So we use AST tree to parse their code, and then we also use AST to do some secure checking to see to make sure they are not sending malicious code to us or whatever bad to us, kind of like that. And then, like you just see, for a front end, for a game side front end, we use Pygame, and for a game engine, we use Pygame. But if you're a game developer, don't judge me for that. I'm not a professional game developer, so yeah, we just use Pygame. And then for the backend analysis tracking system, and then teaching system for system admin system for teacher, for students, we use Django to tackle the APIs and then data. Okay, so okay, just move on. Check time. Okay, so the code execution, like I said, we had a customized code editor, and then when the user click submit, and then we will get their code, and then we will check the safe. We'll do the safe validation first, and that is sub process, and then we initial our function. If you want to see it, I could briefly show it, but yeah, let's see if I have time. But yeah, we have custom function to see if it's malicious, and then we use AST, like I said. So we use AST predefined methods, or we also do some custom methods or functions to do the safety check. But so for people who you don't know AST, I could give supplements or additional materials to the Slido later, because I don't believe we have time to go that deeper. But I just give you a brief idea here. We use AST and then real code sysadmin process, and then we do a security check. So for like as you just saw, we got some predefined objects and methods. So we predefine them, and then we check. When you write whatever code here, we check if they are our predefined objects or methods, or if you are building Python's object or methods, and then if you are not throwing bad stuff to us. So we check whatever you write is allowed, and whatever you write is valid, at least to us. Yeah, and then we blocks whatever commands we analyze, because we'll parse it, use AST. So if you are trying to give us some file system access commands or whatever so-called bad commands, will block it. Yeah. But it will also get your code to store it, to analyze, but it will block your actions. Yeah. Okay. Because there is some keyway. Okay. So this is a very high level and overall idea. So we write some sub process and do timeout mechanism, and then we use a proxy for API as well, and then we use AST walk, and then we basically we'll walk through the tree, and then use a lot of different predefined or not predefined algorithm to walk through the tree, and then to try to customize our needs. And then the third one is comprehensive error reporting. We will record the logs to our internal team and do some analysis. Okay, and then for a code analyzer, and it's kind of like related to the code editor we just built. So for a code analysis tool, so we design. So this tool is designed to completely examining students' submitted code, ensuring accuracy, and then stuff like that. And then we do the data collection, like I just said, and then we could analyze the code, and we got some. In the future, because we're still building that, but in the future we got some prediction to their action, and we'll provide actionable or customized feedback to them using the game characters, so they feel. So it's not the system errors; it's the kind of like a fairy telling you that you're not allowed to do so, or there are some bugs, or there are some errors, stuff like that. Okay, so like I said, we use Pygame. So I just briefly use introduce Pygame because it's PyCon, so but we use Python a lot. So this is we use Pygame. Pygame is a game framework using Python, and some features like sprite handling, collision detection, animation, event processing. For me, who are not professional game developer, Pygame is really a good choice to build this kind of because we are still an educational product. We are not a professional game. Yeah. And then our implementation, wrapper, stuff like that. And I'll just briefly introduce a little bit how we draw the map and then how we embed this to the Pygame. So we use PyTMX. The extension is TMX file. And then we use a tool called Tiled. And I believe there are so many other tools. You could edit the TMX file. And the TMX file, you could draw whatever areas you need to block, or the areas you could go, not to go, and then whatever design you want to put in. And then you could put the design with the coding concepts or educational concepts. So if you're a teacher, and then we will release that feature in the future, that we will allow teachers or admins to create their own maps with their professional, with their expertise. So they could create a very advanced or complex, maybe they want to teach B plus tree, and then I don't know how to visualize B plus tree. Maybe and then we provide some materials and the methods. You could try to make a level or challenge to wrap your very advanced or complex coding concept to the game, and then you could share to the public, or you could share to your students or whoever. You could, and as well, you can make your own quest to your student or your class. Yeah. Okay. So I don't think I will go deeper to Django because this is not that important to the topic. So for Django is a framework for backend, and it's Python, and we use this. We build our APIs using Django, and then we do the big Django got a MTV structure, and then we use ORM to manipulate the database, this kind of stuff. So basically, you just want if you're not familiar with Django, I'm sorry, I'll provide additional materials. But basically, we use Django, this framework, to build our backends, and then data related tasks. Okay, so I just want to share when we are building it, what challenges we faced, and then if we solve it or not. So for the sandbox execution, the security is really important, and then sandbox execution, preventing infinite loops and stuff like that. We use AST tree to solve that, performance, hardware, stuff like that. Cross function, yeah, because we're in time. Let's just move on. But I just want to share this video, but you could see this as on our YouTube as well. But I just want to show it, like how kids really enjoys it. Yeah. And this is our real MVP. So the right hand side is not that good looking at the beginning. Yeah. So the elementary schools, the kids can really type real code, as you are seeing right now. And then if you look at their face, they are so excited. Even they are writing code. Okay, I'm sorry. That's it. Let me go to the next slide. Okay. Yeah, it's kind of like ending. So I just switch back to the educational stuff again. So how we balance fun and learning. I just showed you, and then scaffolding. This kind of terminology you could just ignore if you're not interested in that. And then we'll do some assessment as well. So it's a game, but it's also an educational platform, and then that really teach something. Yeah. Okay, let's skip this. Okay, so I think programming can be a child's game or beginner's games or anybody's game, not a boring text. So I believe this is our talk today. Thank you for your attention. And then if you are interested in those quests or levels, you could sign for a free account on the website, or you could scan this QR code to fill out a form for us, and then we will send you an advanced trial license, and then you could play more than the free trial account or version on the website. Yeah. Thank you so much. This is my email and our website. So thank you so much for your attention. Thank you. That's it.
Thanks to our speaker for such insightful talk. We still have a couple of minutes, and now it's Q&A time. So please feel free to enter your question on Slido. Yeah, and the number is 4. Okay.
I'm sorry. I just refreshed it.
Okay. The number is 4517981。那个 Slido 的代码是451791 ，and then you can input your questions, and then it will show on the screen. Or you can just raise your hand. Okay.
Thank you. I have a question, probably like Norton. Like now, I see in order to operate, you need a person in-person interactions. But I wonder, is the long-term goal like to fully open it remotely for people to use it by themselves, or you think in person is like a key element for this?
I think that is a very good question. Yeah. So the video I just showed, or what I'm showing right now, maybe you need a person to teach them or guide them, or physically or online, or using Zoom or Google Meet or something like that. But we will have, right now we don't, but we will have a fully self-learn paced mode. So if maybe we'll do it for free for a few months, and then we will have a subscription plan, and then you could subscribe that, and then you could do the fully paced learning yourself. So you're playing. So like I just see, this is not that fully complete yet, but we will give a very well structured, like you're playing other games like Mario or whatever, and those RPG games. So you could really actually play it yourself without teacher, and then we will provide teaching materials to free accounts, to advanced accounts, or whatever. So you could log into this profile or system to see the teaching materials, or any kind of textbook or slides we write, or the coding exercise we provide to you. So the self-paced learning is totally possible in the near future, and we will do that as we already planned. Yeah, thank you so much. Yes.
It's impressive that I saw you have a slide showing the conversion or translation from the exception to something that is much more discernible. Now, how did you do that?
How did I do that? So, okay, this is a very complicated question. So we could talk about more later if you're interested. But we basically, this is a very hard question to answer right now using a few minutes. But we basically just do some customized function, and then to see the inputs, and then we just we do our customized analysis, and to like the error message you just saw, like for example, like you're missing a syntax error, you're missing a semicolon, stuff like that. But we do receive this kind of error message in our backend as well. But we categorize, or we kind of do some mechanism to categorize them, and then we try to provide them an interesting text, that is corresponding, or that fits to our plots, and then we just throw back to them this interesting text first, But if you want to see the actual error message, you could see that as well in the code editor. But this is a brief answer. Yeah, that's it.
Okay, is anyone have questions? We still have a couple of minutes. Is there any K-12 teachers or educators in this room?
Hey, hi guys. I actually have my own little company called Steamworks. We're actually down in Chiayi or Begang. I teach kids using Little Bits, and I teach them Python, but we usually use Pygame, and we actually use hardware. So I really love the way you guys do it, but are you going to make it more of like a story paced? Is that the idea?
Yeah, that's the idea.
And then are you going to go with like AI agents to kind of teach the kids?
Yeah, we will. Yeah, we will. We're doing that feature right now, and we'll release that very soon. Yeah.
Okay, and are you guys looking to expand your team as well?
What's that question?
Looking to expand or bring on new members?
Yes, we are planning to. So
Okay.
if you, we could talk later. Yeah.
Yeah.
Yeah. Thank you.